So, we had mentioned that charge is measured in coulombs, and we will be representing that by a letter in all of our formulas. And unfortunately, the letter C is already taken by charge. So we've used the letter Q for the quantity of charge that we have. So that's what we'll use in formulas. Current, again, the letter C was already taken. So we're going to represent that with the letter I. And it's typically measured in amps, which we abbreviate with uppercase A. And time, in science, we measure that in seconds. There will be a few cases where you won't use a second, but whenever we want derived standard units, we're going to want to use a second. And we use a lowercase t for that because uppercase T is temperature. So by definition, we said that current is the rate of change of charge. So that gives us the formula I equals Q over T. And we can do some very simple algebra, like say, for example, if we multiply both sides by T, we get that in terms of Q. And then if we divide that one by I on both sides, we get it in terms of T. These are all really just three forms of the same equation where we're just solving for a different letter by plugging in the amount instead of having to do algebra later. So we do the algebra beforehand with the actual formulas so that we can just plug in what we want and get the answer out. And we tend to like to put equations like that in a equation triangle. And with an equation triangle like this, we can just cover the one that we don't know, and we'll get the equation in the format that we want. And we'll see how that looks like in the sample questions. So, for example, the first sample question that we're given is that a circuit moves 12 coulombs of charge every 4 seconds. So how much current is flowing through the circuit? So what I always want us to do when we're doing these kinds of questions is, first thing, identify what we have and what we need. Okay? So when we read through this question, we see 12 coulombs of charge. It's really nice. It tells us the concept and gives us the unit. But if we just saw the term 12 coulombs, we could look at our chart of what's what, and we could see coulombs there. And we could say, oh, that's charge. And they say, oh, and that's going to be represented with the letter Q. So we'll just make a little note of that. That's the letter Q. All right, so every 4 seconds. Oh, well, 4 seconds, that's time. My time is 4 seconds. And then it asks, how much current is flowing through the circuit? So I'm solving for current, which is represented with the letter I. Right? And I just look those up in each of my chart over here. I get everything I need, and we plug it in. So we figure out what the formula is. So we're looking for a formula that has Q, I, and T. Right now I've only shown you one formula, so it's obviously this one. But down the road, you'll actually have multiple formulas. So you say, oh, this one has Q, I, and T in it. And the thing I don't know is I. So I kind of cover that up. And I see, what am I left with? Oh, Q over T. So I is equal to Q over T. And then I plug in the numbers. And as I'm plugging in the numbers, it's always a good idea to ask myself, are these the standard units? Are these standard SI units? Because if they're not, it's not going to work unless I convert them. So 12 coulombs of charge. Well, that is the standard, so I can just plug in the number 12 here. Divided by 4 seconds. Second is the SI unit of charge. So if I'm plugging in SI units of charge and SI units of charge, then I'm going to get back an SI unit of charge. So if I'm using coulombs and seconds, my answer is actually going to come up in amps. So I can do the arithmetic here. 12 divided by 4 is 3. But that isn't the end of things. Sorry, my screen is really buggy. That isn't the end of things. If I've got 3, well, 3 what? 3 amps. Your answer is not correct without a unit. So you will lose marks if you don't have your unit there. So it's 3 amps of current moving through that point in the circuit. Does that sort of make sense? So let's look at the next question together. how much charge is moved by a circuit running at 0.4 amps for 2 minutes. So what do we have? What do we need? How much charge? Oh, charge. That's one of my actual words. That's Q. And that's the thing I'm looking for. That's the thing I don't know. Okay? So I'm going to solve for Q. What do I have? So, well, 0.4 amps. Oh, amp. I remember that's the unit of measurement for current. So my current is equal to 0.4 amps. Sorry, whenever I write too quickly, it advances the slide. This is about my 6th or 7th time doing this video, so I'm just going to leave it be. And 2 minutes. Uh-oh. Alarm bells need to go off when you see the word minutes. Minutes are not seconds. We need to convert that if we want our answer to come out in standard SI units. We need to use standard SI units, and a minute is not one of them. So 2 minutes, we need to actually convert that. So when we've got our time, we need to actually convert that. Well, how do we convert minutes to seconds? We multiply by 60. 2 times 60 is 120. So our time is 120 seconds. So now we can plug those into the right form of the equation. So in the original formula triangle, we can look at that, and we want to cover what we don't know. We don't know Q. So what are we left with? I times T. Oh, Q is equal to I times T. So we plug that in. And I wish I had better technology. Oh, no. Now, I'm not sure what to do when it actually is exiting out, because it's exited here. I'm not redoing it again. I've already done this 5 times. I'm just starting it again. All right, so we determined Q equals I times T on my terrible divisional technology. And not at all upset with it. So Q equals I times T, and we're going to plug those in now with what we had worked it out for. So we have 0.4 amps times 120 seconds. Remember, we converted that. And now I can do the arithmetic. So 0.4 times 120 seconds that's 4/10 times 120. Or I can multiply the left side by 10 and divide the right side by 10 to balance things out, make it easier for mental math. So it's 4 times 12 is 48. If you're not great at mental math, there's no reason you can't use a calculator for these things, though. So 48 what? Well, what do we measure charge in? Coulombs. And because I started out with standard SI units, I get SI units out. So that's my final answer, 48 coulombs. So that's how we do those types of questions. And we'll go back to Hemabot and look at a new concept.